Hello, my name is Andrew Grant, and in this video we'll be looking at C++ modules with CMake and the Clang compiler. Okay, before we begin, you will absolutely need the very latest version of CMake, which is currently 4.0.2, and the latest version of Clang, which is version 20.1.4. I'll leave you to get them, simply because I don't know what system you're running or when you're watching this video, and the versions will almost certainly have increased within a very short time after this video's been put up on YouTube. Now I'll be upfront here. I can quite honestly say I'm not a fan of CMake, not in the slightest. However, it's got one job to do, which, so long as you get everything inconsistent, incomprehensible, or just plain baffling right, it does really well. As you can see on the screen, we've got a simple project which has a remarkably simple folder structure, just so we have easy access to each module. So first we'll have a look at the CMake presets JSON file, which enables the use of both the Microsoft and Clang compilers in debug and release modes. I've not set up the environment for the release with debug info or for the minimum size release configurations, as this is a completely disposable project. I really didn't see the need. And here we have the top level CMake list.txt file. As I've mentioned, I'm not a huge fan of CMake, so I generally try to automate as much of the configuration as possible. First, we set the CMake minimum required to the very latest, and then we get the project name, which in our case is the name of the project folder. Now we'll move on to the various compilation requirements, and we'll set the standard to the latest, 23, and we'll make that a requirement. After this, we enable the creation of the compile command.json file, and then we'll ensure that the scan for the modules flag is set to true. It's normally set to true, but we'll just make sure, simply because you never know, it's CMake. And finally, we'll add the directory where the code lives. And now we'll move on to what I usually refer to as the management layer. I always like to keep this as simple as possible. Well, we all know management. The only thing you have to pop in here are the higher level directories within the project. The function which you use to run the library or application should be the last thing in the list. In this case it's run. This ensures that compilation is undertaken correctly. I've discovered that if this is anywhere but here, you can get some rather odd messages and errors which make absolutely zero sense. Then we'll add the different directories to the project. This is to ensure that the main function is as clean as possible. I have a serious dislike of cluttered and complicated main functions. Then we'll add the executable with only the main entry file listed. And now we'll target the include directories with the relevant binary directories. And almost the last thing is linking the libraries, which are all named after their containing folder, so we'll just use the DIRs list. And after this, it's always a good idea to ensure that the compilations follow the latest standard. Create a compile feature just to do that. And now we've got what I generally call the worker layer. It's a CMake list.txt, and again, I'm trying to keep it as simple as possible by automating literally everything. As I generally like to use the folder name as the library name, we'll just get that automatically and use it to set the library name. And I find it rather helpful to define the folder name with what the code in here is going to do. Then we'll set up a list of the relevant files, the primary module being the first in the list. This is quite important. The engine behind CMake gets a tad confused if you don't put the primary module first. If there are multiple primary modules, which in reality there really shouldn't be, put the most significant primary module first, followed by the other modules, in the order with which you call them. Order does seem to matter here. After doing this, list any libraries we'll be using with this module. Again, order seems to matter. Place the libraries in the order they'll appear in the module. It just seems to make the whole process easier, quicker and safer. Then it's the target sources bit, followed by the target link libraries, and then just to be on the safe side, we'll do the compile features, listing the library name and setting it to the latest standard. If you have libraries which are not in the direct path for the module, you can pop in a small routine that will link the libraries, though to be quite honest, you do have to be quite careful and ensure that the paths are totally correct. A misstep can cause all sorts of errors, but nonetheless frequently useful, so quite possibly worth spending the time ensuring that the libraries are correctly linked. And here's an example from another worker layer, more commonly known as a folder. As you can see, it's basically the same as the previous CMake lists file. The difference being that the files included in the file list and the libraries being utilised. After that, we've got an add directory for the libraries, which in this case should only be the subdirectories of this folder. Everything else is exactly the same. Like I say, automate as much as you can. It don't half save some time and effort. And now we've got a module. And because we're using Clang, we have to declare the module and include the relevant header files. A pre-compiled header file doesn't always work very well, so just include the header files. The CMake method of creating an import stud is at the moment tad unstable, so we'll leave it alone for just now. But then we can export the module and do everything else as a normal module does. And in the main file, we'll include all the relevant header files, and then we'll import the module that we need. In this case, it's run. And after that, we'll just do the entry function and do what you normally do in an entry function. And we'll make sure to select the preset for the Clang debug and click build. And with eager anticipation, click the run button and break out the coffee. We succeeded! The first output is what we normally get. We'll verify it's all good by running the app again with an input argument. Definitely coffee time. And with that, we'll finish here. This is rather a big topic that will attract a lot more attention over the coming months. But you should now have at least a smattering of an understanding of how it all works. So with no further ado, thank you for watching, and I'll see you in the next video.